In the skies above a remote testing range, a swarm of drones buzzes menacingly towards its target. Suddenly, the air erupts with rapid-fire blasts. Precision-guided rounds streak through the sky, detonating with pinpoint accuracy. Within seconds, the threat is neutralized, leaving only falling debris where the drones once flew. This is the cannon-based air defense, or CBAD, system in action, one of Northrop Grumman's groundbreaking answers to the evolving challenges of modern warfare. As unmanned aerial vehicles and cruise missiles become increasingly prevalent threats, CBAD stands poised to revolutionize air defense. CBAD aims to harness the power of advanced cannon technology and cutting-edge ammunition to create a flexible, cost-effective defense against aerial threats. The system employs a variety of gun calibers, from medium to large, each loaded with Northrop Grumman's state-of-the-art guided ammunition. When a round leaves the barrel, onboard sensors activate, guiding the projectile toward its target. A sophisticated proximity fuse detects when the round is close enough to the threat. At the optimal moment, it detonates, unleashing a hail of lethal fragments that shred incoming drones or missiles. This approach drastically reduces the number of rounds needed to neutralize a target, making CBAD both efficient and economical. The system's cost-effectiveness is a significant advantage. Traditional missile-based air defense systems, while effective, come with a hefty price tag. Some interceptor missiles cost up to $4 million per round. In contrast, CBAD offers a solution that's not only more affordable, but also more sustainable in prolonged engagements. Its high-capacity magazine and rapid-fire capabilities make it ideally suited for defending against swarm attacks, a growing concern in modern warfare scenarios. Versatility is another of CBAD's key strengths. It can be integrated into existing air defense networks, complementing long-range interceptor missiles by providing a crucial layer of short to medium-range protection. Its modular design allows for easy adaptation to various platforms, from stationary installations to mobile units, ensuring that defensive capabilities can be rapidly deployed wherever they're needed most. Far from just countering drones and missiles, its precision-guided rounds can also eliminate ground targets, making it a true multi-role system. This could prove invaluable in complex battlefield environments where threats can come from multiple domains simultaneously. While the system shows immense promise, it's not without its challenges. The complexity of guided ammunition raises questions about its reliability in harsh combat conditions, and its effectiveness against more sophisticated, high-speed targets is yet to be fully proven in real-world scenarios. However, ongoing tests and improvements suggest that these hurdles are likely to be overcome. Meanwhile, Northrop Grumman continues to push the boundaries of CBAD's capabilities. The company is actively developing new ammunition types to further enhance the system's effectiveness. A programmable airburst munition is in the works, designed to defeat targets in defilade, such as infantry behind cover. Even more intriguing is the ongoing development of a guided munition aimed at extending CBAD's reach and lethality even further. The potential impact of CBAD on future conflicts is profound. Its ability to provide affordable, sustained defense against a wide range of aerial threats could fundamentally alter the calculus of air superiority. Adversaries who might have relied on overwhelming defenses with sheer numbers of low-cost drones or missiles will now face a formidable and cost-effective countermeasure. As global tensions simmer and the nature of warfare continues to evolve, CBAD stands as a testament to American ingenuity and technological prowess. While challenges remain in its full implementation, this innovative system promises to be a game-changer in protecting troops, critical infrastructure, and civilian populations from the ever-growing threat of aerial attacks. Yet CBAD isn't the only weapon revolutionizing air defense. As battlefields become increasingly dynamic, a new system emerges, bringing robust protection to the very heart of mobile combat units. During a NATO exercise near Poland's eastern border, a convoy of armored vehicles advances across the countryside. Suddenly, the lead vehicle halts, its turret swiveling as sensors scan the horizon. The air fills with a growing buzz as a simulated threat appears, a swarm of small, unmanned aircraft rapidly approaching. Within seconds, the vehicle's defense system springs into action. A hail of precise fire erupts, and in the blink of an eye, the mock drone swarm is neutralized. This formidable guardian is the M-SHORAD, recently dubbed Sergeant Stout as a tribute to Sergeant Mitchell William Stout, who was posthumously awarded the Medal of Honor for heroic actions in the Vietnam War, the only air defense artillery soldier to receive this most prestigious of decorations. The system embodies its namesake's valor and the cutting edge of mobile air defense technology. Sergeant Stout marks a decisive leap forward in battlefield protection. Mounted on the combat-tested Stryker platform, it fuses agility, firepower, and sophisticated sensors into one potent package. This amalgamation enables it to match the pace of rapid maneuver forces, while offering persistent defense against airborne threats. The system's armament is nothing short of impressive. An XM914 30mm cannon forms its backbone, supplemented by an M247.62mm machine gun and an array of Stinger missiles. This diverse arsenal allows Sergeant Stout to counter airborne dangers, from tiny drones to attack helicopters and low-altitude jets. The flexibility of this loadout ensures that Sergeant Stout can adapt to various threat scenarios, providing comprehensive protection for ground forces. Equally remarkable is Sergeant Stout's sensor suite. Its multi-mission hemispheric radar delivers all-around aerial surveillance, tracking multiple targets simultaneously. Coupled with advanced fire control software, this allows for swift identification, prioritization, and engagement of threats with unparalleled speed and precision. The system's ability to process vast amounts of data in real time and make split-second decisions is a testament to the sophisticated AI and machine learning algorithms at its core. Another of Sergeant Stout's standout features is its ability to fight on the move. Unlike its stationary predecessors, this system can spot, track, and neutralize threats while rolling with the convoy. In today's high-tempo combat environment, where pausing to deploy air defenses could spell disaster, this mobility is a game-changer. It allows for continuous protection of maneuver forces, filling a critical gap in short-range air defense capabilities. The path to Sergeant Stout's creation was paved with urgency. Years of focus on counterinsurgency left the U.S. Army with a critical gap in short-range air defense. The emergence of near-peer adversaries in the drone revolution highlighted this vulnerability. Recognizing the pressing need, the Army expedited Sergeant Stout's development, bringing it from concept to field in under 4 years. This rapid development cycle showcases the adaptability and innovation of the American defense industry. Sergeant Stout's battlefield debut has been promising. In 2024, during the Defender 24 exercise in Poland, a half-dozen vehicles showcased their prowess in live-fire drills. The results were striking, with the system successfully neutralizing targets ranging from small drones to simulated cruise missiles. These exercises not only demonstrated Sergeant Stout's abilities, but also provided valuable data for further refinements and improvements. However, the system's impact extends beyond its direct combat capabilities. Its presence on the battlefield serves as a powerful deterrent, forcing potential adversaries to reconsider the use of air assets in contested areas. This psychological effect amplifies Sergeant Stout's effectiveness, potentially altering enemy tactics and strategies before a single shot is fired. While Sergeant Stout's potential is enormous, it's not without hurdles. Integrating multiple weapon systems on a mobile platform presents intricate maintenance challenges. Its effectiveness against advanced threats like supersonic missiles is still being honed. The complexity of the system also requires specialized training for operators and maintenance crews, adding to the logistical considerations of deployment. Yet, ongoing refinements are tackling these issues, promising to enhance its already substantial capabilities. Engineers are working on improving the system's power management, enhancing its ability to operate for extended periods in austere environments. Software updates are continually improving target recognition and engagement algorithms, making Sergeant Stout smarter and more effective with each iteration. The future of Sergeant Stout looks even brighter. Plans are already in motion to expand the system's capabilities. The Army is developing new variants, including one equipped with a high-energy laser. This directed energy weapon promises to add yet another layer to Sergeant Stout's already impressive defensive features, potentially offering a near-infinite magazine for engaging certain types of threats. As geopolitical tensions simmer and warfare evolves, Sergeant Stout stands ready to meet emerging challenges. Its swift development and deployment underscore the United States' dedication to field superiority. The system's ability to integrate with existing battle management networks allows it to serve as a crucial node in the Army's broader air defense strategy, sharing targeting data and coordinating responses with other assets. Though work remains to fully integrate this complex system into existing military frameworks, Sergeant Stout is already proving its mettle, solidifying its role as a key defender in modern combat scenarios. From the mountains of Afghanistan to the plains of Eastern Europe, the concept of air defense has been redefined. Its combination of mobility, firepower, and advanced technology makes it a true force multiplier, capable of protecting troops and assets in even the most challenging environments. But the evolution of chain gun technology doesn't end with Sergeant Stout. From the skies above, another weapon system descends to the ground, bringing the power of aerial warfare to an even wider range of combat scenarios. The rhythmic thunder of rapid fire pierces the air. Rounds streak across the battlefield with deadly accuracy, neutralizing threats and clearing paths for advancing troops. This symphony of destruction emanates from the M230 LF cannon. Born from the legacy of the M230, the famously fearsome chain gun used by the iconic Apache helicopter, the M230 LF, which stands for Link Fed, embodies the pinnacle of medium-caliber firepower. Northrop Grumman's engineers have transmuted this aerial powerhouse into a versatile asset for ground and naval operations, crafting a system that excels across diverse combat scenarios. At its core, the M230 LF is a 30mm automatic cannon that marries raw power with surgical precision. Unleashing a torrent of 30 by 113mm munitions at 200 rounds per minute, it can neutralize an array of threats. From lightly armored vehicles to entrenched positions and even low-flying aircraft, the M230 LF's adaptability makes it an indispensable asset in today's multifaceted conflicts. What sets the M230 LF apart is its innovative chain gun mechanism. Eschewing traditional recoil or gas operation, it harnesses an external power source to cycle its action. The result is exceptional dependability, with a staggering 22,000 rounds between malfunctions. In the unpredictable theater of war, such reliability can be the decisive factor between victory and defeat. Transitioning the M230 from air to ground presented unique challenges as engineers grappled with maintaining its potency in a new domain. They extended the barrel to preserve muzzle velocity at ground level, overhauled the recoil system for various platform integrations, and incorporated an anti-hang fire mechanism to safeguard crews working in close proximity. These adaptations showcase the ingenuity required to transform an aerial weapon into a ground-based powerhouse. Perhaps the M230 LF's most groundbreaking feature lies in its ammunition. It fires an array of specialized rounds, each tailored for specific scenarios. The high-explosive dual-purpose, or HEDP round stands out, capable of piercing light armor while generating a lethal fragmentation effect. For anti-air operations, the high-explosive proximity, or HEP round employs a radio frequency fuse, detonating near aerial targets and unleashing a devastating fragment cloud effective against drones and light aircraft. Adaptability is another of the M230 LF's strong suits. It integrates seamlessly into remote weapon stations across a spectrum of platforms, from agile tactical vehicles to naval vessels. This flexibility allows it to deliver overwhelming firepower wherever the mission demands, be it urban peacekeeping or maritime defense. In an era of asymmetric warfare and proliferating unmanned threats, the M230 LF has found its niche. Its capacity to rapidly engage small, swift targets makes it an ideal counter to the growing drone menace. Combined with advanced fire control systems, it can create a nearly impenetrable defensive bubble against enemy UAV swarms. The cannon's impact is evident in its widespread adoption. Not only has it become a cornerstone of the U.S. Army's M-SHORAD program, where it is known as the XM914, but the Marine Corps has also recognized its potential, incorporating it into their MADIS initiative. At the same time as combat dynamics shift, the M230LF continues to evolve. Northrop Grumman's team is pushing the envelope of possibility, with current projects including a dual feed mechanism allowing on-the-fly ammunition switches and advanced guided munitions to extend the cannon's reach and lethality. Nevertheless, while the M230LF boasts impressive capabilities, it's not without its challenges. Its size and power requirements can limit integration options on smaller platforms, and its effectiveness against heavy armor is outmatched by larger caliber weapons. However, ongoing advancements in ammunition technology and integration solutions are addressing these constraints, further broadening the M230LF's already considerable versatility. The global impact of the M230LF is undeniable. Over 1,400 units are now fielded worldwide, from the scorching deserts of the Middle East to the dense jungles of Southeast Asia. Looking to the future, the M230LF is poised to play an even more significant role in integrated defense systems. Its ability to seamlessly coordinate with other sensors and weapons platforms makes it a vital component in network-centric warfare. As battlefield communication and coordination continue to advance, the M230LF's versatility will likely make it an even more valuable asset. The M230LF's journey from air to ground exemplifies a forward-thinking approach to defense, rising to meet the challenges of increasingly complex conflicts. Despite ongoing efforts to maximize its potential across all combat scenarios, the M230LF's combination of firepower, accuracy, and versatility ensures a decisive edge from urban zones to open plains and coastal waters. Its distinctive roar serves as both reassurance and deterrent, while its ability to be reimagined and repurposed for evolving threats keeps it at the forefront of military technology, not just keeping pace with the changing face of warfare, but actively shaping it.